Hello all, welcome back. So today we are going to start new series, System Dynamics and Control. This series is going to help for those who are working in this field and for those who would like to learn and understand from fundamentals. So we will cover from fundamentals, so there will be no problem to follow this series. All right, so let's get started. So in this, like part 1, we would like to cover like introduction and its applications. Okay, so there are various applications where we can use the control systems. Okay, then we will move on the control system, how we can define the control system. Okay, and then we will also highlight the advantages of control systems. All right, so here we can see, like control systems are an integral part of the modern society. Okay, there are various applications, so let us understand and touch all application one by one. You can see rocket fire. So rocket fires also we use the control system to control the launch vehicle. We will discuss later more details in this. Okay, and space shuttle lift off to Earth orbit. So in this also we use the control system, and our and is placing in cooling water. Here we also use the control system. Okay, a metallic part is atomically machined. This also only possible to it controlled by the once we develop the control systems. And like self-guided vehicle and delivering material to workstation in aerospace assembly, plant glides. Okay, this is like you can say assembly plant. So here we can self-guided vehicle, it can deliver the material to workstations along the floor seeking its destination. Okay, so we know which floor it would want to reach. So based on that, our vehicle can reach this destination. So point is that here there are various application. Control system plays important role, as we saw rocket fires. Okay, so without control system we cannot control rocket and follow the trajectory. So that's a very important. So we will not cover more in this part, just I am just touching this. Okay, this also comes under the guidance navigation control systems. So we will cover this over another series. All right, so here there are just a few examples of atomically controlled system that we can create. We are not only creators of atomically controlled systems. Okay, if you observe the nature also have um, perform the activity in a controlled way. So let us see, the system also exists in nature. So within our bodies, like numerous control systems such as pancreas, which regulates our blood sugar. Okay. So in time of fight and flight, our adrenaline increases along with our heart rate, causing more oxygen to be delivered to our cells. Our eyes follow a moving object to keep it in view. Like one object there, it's moving. Okay. So in order to view, so our eyes also follow this moving object. Then only we can view, we can see the object, right? And like our hands grasp the object and place the precisely at a predetermined location. Okay. Whenever we grasp any object and place precisely in a predetermined location, intended location, like whenever any object we can pick up, okay, and we can place somewhere. So this also part of control. Okay, because hands also working like robotic, or we can say. Okay. So here we starting series from examples so that we can build up our intuitive understanding about control systems. Okay. And we understand the importance of significance of control systems. So even a non-physical world appears to be atomically regulated. Okay. So models have been suggested showing automatic control of student performance, like any model if we develop. Okay. And our intention that the input of model, let us say this is input and this is your output. Okay. This is like model. Okay. We will see what is the model in later. So it tells about you know input to model is a student's available study time and output is grade. So what is the time student give the time to study, and what is the output is gives in terms of grade. Okay. So model can be used to predict the time required for grade to rise if a sudden increase in a study time is available. Okay. So we develop the such model where we give the input in terms of study time and output it will provide in terms of grade. So whenever we increase the time, the study time, so it will also impact on the grade. So that's we want to understand. So this also like one case study we can say this also is a of control system. Okay. So using this model you can determine whether an increased study is worth the effort during the last week of term. Okay. So here we can see whether when we increase the time how much impact we can see in terms of grade. Okay. How much is worth. Okay. So here we have understand there are a lot of various applications daily use we can see. Okay. So we started to build up our intuitive understanding. All right. So that's the things. So here we can understand like if you want to predict it still be required the control system model. Okay. So model, let us understand like what is a model actually. Like this consists of the like subsystems like some mathematics you know it will be helpful to, you know based on your input, based on your output. Okay, it will provide your desired output, and helpful in understanding the system performance, how system behave over time. Okay, so let us we go move on the system control system definition, how we can define the control system. Okay, so basically control system consists of subsystems. Okay, and process and plants. Here we need to understand the for some terminology generally we are using in control system, which uh, system or we can say any physical body, any physical system we want to control, this called the plants. Okay, let us say like a car. Okay, car, like you can say robot. So robot is also like a plant. Okay, sometimes we also call the process. Okay, in chemical industry generally we call the process. Okay, because here we want to control the process. Okay, using the control. And control system, they are consist of subsystems. Okay, interconnected. Okay, and our main focus that they are assembled for purpose of obtaining the desired output with desired performance. That's a very important to understand what we want. Actually we want desired output with desired performance. Okay, so here we are giving the input. Sometimes we also call the our whatever desired input we want, the desired response we want, we will give the as a input. Okay, this like a behave like a stimulus. Okay, we are stimulating the process control system. Okay, so basically like you can if you want to draw like this a control system, this a control part, and this are the plant. Okay, okay, so we will discuss later the types of control systems. Okay, so our main focus that we want to achieve the desired output with desired performance. So we will see what the desired performance. Okay, so figure shows the control system in simplest form where the input represents a desired output. Okay, so whatever input we want we have to give in a terms of input. Whatever desired output we want we have to provide in a input. Correct. So here you can see, let us understand this more better in a concept. One example like elevator. Nowadays frequently we are using the elevator. Okay, if you go, you know in a metro station, elevator there. Okay, in mall also elevator there. So latest example like when the fourth floor button is pressed on the first floor, we are in first floor and we want to go there fourth floor. Okay, okay, so how to achieve it? So like you can see in this elevator response, so this like a location, this is like first floor. Okay, this like fourth floor. Okay, so elevator location flow you can see here. It will start, will behave like that. Okay, and try to achieve it. So here you can see there are the two response. One is a transient response and second one is a steady state response. Okay. So here you can see this transient response. Okay. Two things there. One is a speed and how much we are leveling the floor. This called the in elevator example we can say this is a steady state error. How much far away? Okay, from the floor, our intended floor. Okay, so the elevator rises to the fourth floor with a speed and floor leveling accuracy designed for the passenger comfort. Okay, that's a very important. Like a steady state error should be very negligible. This our desired performance. Okay, and here you can see there are two parameter, two desired speed and floor leveling accuracy. Okay, so to push of the fourth floor button is an input. This is like input whenever we give the push to the fourth floor or some other floor, that represents our desired output. So basically input we are giving the our desired output. Okay, we are feeding our desired output in input itself. Okay, so here you can see our previous slides. Input itself we are giving the our desired output. Okay, so all right, and that represents our desired output shown as a step function figure. You can see this like a step response we are giving the fourth floor. Okay, so we will cover like what the kinds of response we can give. Okay, so here performance of elevator can be seen from the elevator response curve in the figure. Okay, how performance you can see here, how it's behaving. Okay, so first initial response, yeah, we can say this called the transient response. Okay, and second one is a steady state response. So for example, consider elevator. When a fourth floor button is pressed on the first floor, okay, so elevator rises to the fourth floor with a speed and floor leveling accuracy designed for passenger comfort. Okay, push for the fourth floor button is input that represents a desired output. Okay, we have seen in the step function in figure. Okay, but the step input we can give here, input we are giving the in step, like let us say this is one floor, this is fourth floor, so this is like a step input we can say. Okay, sudden change in input. Okay, so here performance of elevator can be seen in elevator response curve in the figure. So I told they are the two major performance. One is a transient response and second one is a steady state response. Okay, so here in a steady state response, basically in our elevator, we can say this is a steady state error is important. Okay, why? In case of our elevator, like we don't want to, like for example this is floor. Okay, we have reached your elevator, so it should be negligible error actually. it should be labeled properly, then only easy to is comfortable for passenger, right? Comfortable for users. Okay, we want to minimize this as much as possible. Okay, so because we have to, whenever we give the step response, okay, so it will be behaving like that also. There are various kinds of response of step, so here our main focus that we have to minimize this error. Okay, and speed we can, it may be less also, there will be no problem. Okay, it will taking more time, but it's all right. But error we cannot be, you know we should be minimum as much possible. Okay, so here I get transient response and HDC response. So in our example, passenger comfort and passenger patience are dependent upon the transient response. Like if we speed very high, okay, so it will not be, I mean, this will not be good for, passenger. Okay, so we have to give the, our like which speed where passenger feel comfort. Okay, and if you give very low speed, it will take more time, so it will be chance to passenger don't want to like to go by, elevator. Okay, so if the response is too fast, passenger comfort is sacrificed. Okay, if response very fast, speed is very high. Okay, if speed is very high, then if it too slow, the passenger patience is sacrificed. So there are two things. Okay, we have to play in between. Okay, so that we can achieve the performance in a, and passengers should also satisfied. And second, another things is that issue error is another important performance specifications, since passenger safety and convenience would be sacrificed if the elevator did not level properly. Very difficult to get down, right? Come from the elevator then, like this floor, and we have reached this. It's very difficult to come from the elevator. So that's also very important. So speed and HDC error, speed should not be very fast, it should not be very slow. Okay, so we have understand the control systems, and we have to understand the, and we have also understand the, like how we can define the control system, and we have built up the our understanding through the, examples. Daily use we can see the application of control system. Okay, our very good application of the elevator. So here we can see generally there are two types of response: transient response and steady response. So in case of elevator application point of view, steady response very important. We have to minimize the error. So transient response, our speed we can minimize, we can play in between, so that it should not be too slow and too fast. Okay, in between we can play with. Okay, so hope we have understood these things. So that's why we started from the example, so that we can build up our intuitive understanding through these control systems. Okay, for the control system. So hope you understood. Okay, so that's all. we will come up with our new part. Okay, thanks all.